Now we are going to learn about partial fractions. Let's start by adding these two fractions together. We remember that the way that you add fractions together is to get a common denominator. So the first fraction is missing the x plus 1 in its denominator, so I multiply x plus 1 over x plus 1 times 1 over x minus 2. This really is multiplying by the number 1. It's just written with so that I'll end up with a common denominator. And then this fraction is missing the x minus 2 in its denominator, so x minus 2 over x minus 2. Now, x plus 1 times 1, the 1 distributes to each term. We end up with x plus 1 over x plus 1 times x minus 2. And the 3 distributes, so 3 times x minus 3 times 2 over x plus 1, x minus 2. But now they have the same denominator, so I can add together the numerators, keep the same one denominator, because that's our procedure for adding fractions. So x plus 3x is 4x, 1 minus 6 is a negative 5, over x plus 1, x minus 2. Okay, now, notice this tells me this fraction can be decomposed into these pieces. How do we do it? We recognize that there's going to be some number over each factor adding together to give us that result. So we're going to break apart fractions that look like this into the smaller pieces like that. And the way that we do that is, first of all, if it's not already a proper fraction, if the degree of the numerator is equal to or more than the degree of the denominator, then it's not a proper fraction. If it's not a proper fraction, I divide first so that I get a proper fraction. Then factor the denominator completely. It will factor into a product of linear factors and irreducible quadratic factors, quadratics that can't be factored into real number solutions. So every polynomial can be factored into a product of linear factors and irreducible quadratics. For each linear factor, we're going to assume that we've got some constant over that linear factor. If a linear factor is repeated, then we include every term up to the order of the repetition. For the quadratic factors, we're going to assume a linear term in the numerator. And again, for repeated, we do that over and over again up to the order of the repetition. Then we're going to solve. Okay, let's see this in action. Let's see how this would work. So if I have 3x minus 1 over x times x plus 1, this is a linear term and this is a linear term multiplying. So I'm going to say it can be broken into something over x plus something else over x plus 1. Now, I multiply both sides by the common denominator. When I multiply by the common denominator over here, it's going to cancel with that denominator and leave just the numerator. Over here, the x's will cancel and I'll have a times x plus 1. Over here, the x plus 1's will cancel and I'll have b times x. Now, I can gather my like terms and equate coefficients and solve for a and b. Or faster, I can say this is true for every single value of x. So notice if I substitute in x equals 0, I knock out the b term. So I would have 3 times 0 minus 1 equals a times 0 plus 1 plus b times 0. So that tells me a is a negative 1. If I substitute in x equals negative 1, this factor will be a 0. So I'd have negative 3 minus 1 is negative 4 equal to a times 0, b times negative 1. So that tells me that b is equal to 4. So I would have a, which is negative 1 over x, plus b, which is 4 over x plus 1, as my partial fraction decomposition of this expression. Let's do another one. Here, the x plus 2 is got a cube on it. So we said when we have a repeated linear factor, we assume that it can break down into a constant over the factor to the first power, plus a constant over the factor to the second power, plus a constant over that factor to the third power. Now, multiply both sides by x plus 2 cubed. Here it'll cancel and leave just the numerator. Here, one of them cancels, so it leaves a times x plus 2 squared. Here, two of them cancel, so it leaves b times x plus 2. And here they all cancel, so I just have c. Okay. So again, this is a case where it's going to be easier for me to multiply this out and collect my coefficients together. So I would have a times, I've got a FOIL here, x squared plus 2x plus 4, plus, distribute the b, bx plus 2b plus c. Now, distributing the a, I would have a times x squared, and I'd have 2ax, but I also have a b, so plus 2a plus b times x. And then 4a plus 2b plus c is a constant. So now this a must equal the coefficient of the x squared over here, so a is 0. This guy, 2a plus b, has to equal the coefficient of the x term over here, so a 2. And this one must equal the constant term, so 4a plus 2b plus c equals 1. Well, now I know from here a is 0, so this tells me b is 2. If a is 0 and b is 2, that's a 4, so subtract it over, c is a negative 3. So this decomposition breaks down into a, which is 0 over x plus 2, plus b, which is 2 over x plus 2 squared, plus c, which is negative 3 over x plus 2. All right, let's look now at one that we've got to factor. So we start by factoring this denominator, and we recognize that that factors into x plus 3 times x plus 1. So that tells me this breaks apart into some constant over x plus 3 plus a constant over x plus 1. Multiply both sides by x plus 3 times x plus 1. It'll cancel here and leave just the 3. Here the x plus 3's cancel and leaves the x plus 1. Here the x plus 1's cancel and leaves the x plus 3. Substitute in x equals negative 1, and you'd have 3 is equal to, a would be a 0, or a times 0, plus b times 2. So b is 2/3, or 3/2, sorry. Now substitute in x equals negative 3, and I'd have 3 equals negative 2a, and that would be 0 times b. So that means a is negative 3/2. So I would say this decomposition goes to 3/2 over x plus 3. Oh, I'm sorry. That should be the a. So that's a negative 3/2 over x plus 3. Plus b, which is 3/2 over x plus 1. But we don't leave a fraction inside a fraction, so I'm going to bring the 2 down in the denominator and make that negative 3 over 2 times x plus 3 over 2 times x plus 1. And that would be my final decomposition. All right, this one involves a quadratic, and it's irreducible. That doesn't factor any. So 2x plus 1 over x plus 1 times x squared plus 2. Over the linear term, it's just a constant. But over the quadratic term, we have a linear on the top, bx plus c. All right, let's multiply both sides by that common denominator. Everything cancels here and leaves a 2x plus 1. Here, the x plus 1's cancel, so I'll have a times x squared plus 2, and then bx plus c times x plus 1. Okay, now, If I multiply out this term over here, I'll have ax squared plus 2a, and then x distributing through plus bx squared plus cx, and then the 1 plus bx plus c. Now gathering together terms, a plus b, x squared, and then c plus b, x, and then 2a plus c as my constant. All right, so this has to equal the coefficient of x squared over here, so a plus b has to be a 0. This has to equal the coefficient of the x over here, so b plus c equals 2. And then 2a plus c has to equal this guy, so 2a plus c is a 1. So this tells me that a is a negative b. So I can plug that in here, replace the a with a negative b, and do elimination with this equation. So I'll have b plus c equals 2, and then substituting in a negative b here, I'd have negative 2b, then just put in negative b here, plus c equals 1. Now let's subtract these two. So b minus negative 2b would be 3b, c minus c is gone, and then 2 minus 1 is 1, so b is a 1/3. So that means a is a negative 1/3. And then c, well, if b is 1/3, this is 6/3, so c has to be 5/3. Okay, so that tells me that my decomposition looks like a, which is negative 1/3 over x plus 1. So negative 1 over 3 times x plus 1. Plus b, which is 1/3 times the x. And c is 5/3. They're both thirds. So I'll put the 3 down here. And I have b, which is 1x, plus c, which is the 5. And there's our decomposition. When it's a linear factor, multiply each side of the resulting rational equation by the common denominator and substitute in the 0 of each factor so that you can solve for the unknowns, a, b, and so on. When it's quadratics in the top, we're going to multiply each side by the common denominator and then collect like terms and equate the coefficients and then solve the system of equations to get the solution.